Okay, let's do a mirror problem. The first thing to remember with all mirror problems are the sign conventions. Anything on the side of your object is positive. Any distance on the side of your object is positive. Any distance on the other side of the mirror is negative. Anything above, anything on top is positive. Anything below would be negative. Sometimes when we get inverted images, we'll get a negative height. Heights going up are positive, heights going down are negative. Distances on the side of the object are positive. Distances behind the mirror on the other side from the object are negative. Concave mirrors are mirrors that look like you're inside a cave. You're inside the curved part. The mirror is pointing at you, at the object. Convex mirrors, the mirror is pointing away from you. Focal length f for concave mirrors is positive. The focal point is on the same side as the object. Negative for convex mirrors. The focal point is on the opposite side. The focal point is always the mirror wraps around the focal point. So here we've got, if you read the question, we've got some object here and a convex mirror. So the mirror points away from the object. That means the focal point is going to be over here somewhere inside the mirror. The mirror wraps around the focal point and it wraps around C, the center of the circle. So someplace over here is F. That means we're going to have a negative F. This side is positive, this side is negative. Convex mirrors have negative Fs, have negative radius of curvature. The radius of curvature, this is the center, this is the radius of the curvature, and that's twice the focal length. Convex mirrors also produce images over on this side. These will be virtual images. Anything over here is virtual, anything over here is real. Convex mirrors always produce virtual images. Okay, so here's our question, and here are all of our formulas we have. Here's our mirror equation. Here's the relationship between the heights and the distances, and then the magnification. Notice that the magnification formula has this extra negative built in where we're relating the distances. Okay, so we've got a shopper standing 3.5 meters from a convex mirror. So DO is 3.5 meters. And we're told the magnification. Because we have a positive magnification, we know our image is going to be upright. Negative magnification means your image gets flipped over. Positive is upright. We know because it's a convex mirror that our image is going to be on the opposite side. Convex mirrors always produce virtual images. So we're going to have some DI, distance to the image, and that's going to be a negative sign. Remember, anything over here is positive. Any distance over here, not the heights necessarily. Any distance over here is positive. Any distance over here is negative. So I'm going to end up with a negative DI, and that'll just pop out on its own. So on which side is the image located? On the opposite side. Okay, now we want to know how far is the image. That's DI. Well, the magnification is the opposite of DI over DO, and the magnification was 0.26. That was given in the problem. So that should be the opposite of DI over 3.5. So when we multiply over and bring the negative over, we get a DI, a distance to the image of negative 0.91 meters. It's negative because it's on the opposite side. This is the negative side. Lenses are different. We're going to do lenses in different videos. The sign conventions for lenses are different. For mirrors, this is the positive distance side, this is the negative distance side. Okay, now we use the mirror equation to find F. So 1 over DO plus 1 over DI, remember DI was negative, will be 1 over F. Okay, now the best way to type this into your calculator, I want to get the calculator. The way I would recommend doing this is do the entire left side first. So 1 divided by 3.5 minus 1 divided by 0.91. If I have a fraction that's negative, I'm never going to put the negative down in the bottom of the fraction. I'm always going to move it to the top or just make the whole fraction negative. And I'm going to hit enter, but that's not F. That's 1 over F. So I could either do 1 divided by that answer. So to get answer, I do second answer. 1 divided by second answer. Or once I've got this answer in front of me, I could just flip it over. I've got this button right here that will take the reciprocal of a fraction. So there's F. Notice F is negative. My focal length is negative for convex mirrors. You get a negative focal length. For concave mirrors, you get a positive focal length. And of course, we need units. And then we want the radius of curvature. Radius is just twice the focal length. And we always want to be careful here. In part B, they just wanted the absolute value. So even though DI was a negative number, negative 0.91, I already said which side it was on here. I've already taken care of the negative. So part B, they just wanted 0.91. But for the rest of these, they did want me to include the negative. So I would have my negative number for focal length and twice that for the radius of curvature. Again, this is a negative. And here are all the numbers. And that's a good place to stop with this one.